All right, look at number 1 with me. This is on worksheet 5.1, worksheet number 5. Number 1. Well, first thing I notice is that they have got different functions in there. And we can't factor this unless we notice that there's a same function in both parts. Do you see that on A there is the same function in both parts? So 2 cosine x and then sine x. And then the other part's got a cosine in it too. Minus cosine x equals 0. Okay, this got a sine, or sorry, cosine, that's got a cosine. So if they have something in common, you can just factor it out. This is the easy kind where there's just a cosine in both of them. When I pull that out, I'll have cosine in front, and then I'll have 2 sine x minus, and so many people don't know what to do on this. What if you take the cosine away? Do you just leave it nothing there? No, you don't leave nothing there. You have to put something there. What do you put there? A 1. What you're really doing when you factor out a cosine x is you're doing this. See, when you divide by cosine x, that's why it's a 1, because cosine divided by cosine is 1. The other way to think of it is, if you multiply this puppy back out again, you need it to come out to the original problem, which is right there. All right, so now I got it factored. So what? If you've got it factored, then you've got this could equal 0, or that could equal 0. That's called the zero product property, because it's a product of two things being multiplied. This part could equal 0, cosine x equals 0, or this part could equal 0, 2 sine x minus 1 equals 0. Then you solve them down. That one's already solved down. That's going to be simple. Cosine is equal to 0. You're going to be able to draw a nice triangle where the side is 0 over 1? No. So if you can't draw a triangle, you must be at one of those special places. They're called the quadrantals. Means you're either like here or here or here or here. Remember those? So what are those spots? This is 1 comma 0, 0 comma 1, negative 1, 0, and 0, negative 1. Where is the cosine x? Well, cosine is the x, which is 0. So I'm saying basically that x is 0. Which one of these has an x of 0? That one and that one. If we were doing inverse trig, we would only be allowed to be here. Remember that deal? That's if it was inverse trig, but this is not inverse trig. This is regular trig. So I can be at both of those spots. So the answers are in radians. You remember what those spots are called? Pi over 2 is this one. Good. And how about that one? 3 pi over 2. Good. There's 2 answers. Why am I not done? Why can't I just say pi over 2 and 3 pi over 2? Because there's 2 answers for this one also. Stay with me. So I'm going to add 1 to both sides. 2 sine x is equal to 1 then after I added 1 to both sides. And now sine x equals a half. Ooh, I have that one memorized. Sine of what is a half? Yes, usually we'd say 30 degrees, and then you'd change it to, what was it? Pi over 6. Good. Is there another place where sine of 30 is equal to a half? Is there another angle? Sine of something else equals a half? Yes, there is. Where is sine positive? Oh, students take calc. Sine is positive both here, which gives us that 30-degree angle answer, or pi over 6. And sine is also positive there, remember? So if sine's positive there, then we can make another triangle just like that right here. And if that has a 30-degree angle right here, or pi over 6, then what's that angle right there? 5 pi over 6. Yes? This is the part where you're getting scared, like, oh crap, I'm going to fail this test, what's going to happen? So that's when I get the questions like, how much is this test worth? Can you retake this test? So this test is happening on Friday, and it counts in 4th quarter. And of course, because 3rd quarter is over with now, the it'll be your first test of 4th quarter. And then right after that, about 3 days later, maybe 4 class days later, you have a cumulative test where it'd be your chance to fix it if it goes badly. And if you still don't know what's going on, then yeah, you're going to have a bad grade in your grade to start the quarter. But as I mentioned, As long as you try, the last quarter is easier than this quarter. This test is tough. I've said it enough times that I think you believe me. Don't give up on it though. What you want is you want at least to get the easy ones right, so you could lock down a C fairly easily as opposed to a D or an F. If you just, the F's and the A's and the B's will be hard to come by. But a lot of you could lock in a C. All right. Now, I'm throwing this out there just to make you realize how hard it is, so you can either choose to study, or if you don't, just know what's coming. So, okay, let's move on to a different kind of problem. Part B, that's got a square root of 2 in the front of it. That's a little unusual. Does it have anything that could be factored out of both of them? Tangent can be factored out of both of them. Let's start with that. So once tangent comes out, then you've got that square root of 2 left in there still. Square root of 2 cosine x. And then it's minus, and then what do I put for that? 1. Good. There. Now that it's factored, I've got this part. Can I put parentheses around that? Sure I can. You can put parentheses around anything you want to. Well, I shouldn't say that. If it's a single term like that, you can. So if I was doing 5 times 6 and I said, I want to put parentheses around that. Sure, you can. Anyway, back to, I'm going to see that this part has to equal 0. Tangent of x has to equal 0. And then this part over here, I'll do that in green. We're at 2 cosine x minus 1 equals 0. I know why they did that root 2. Because then they'll have a 1 over root 2 is the answer. Get what I'm saying? When I add 1 to both sides, and I get root 2 cosine x equals 1, and then I divide by root 2. 1 over root 2 is something you've seen before. Cosine x equals 1 over root 2. Does that sound like the 1, 1, root 2 triangle? You remember that one? So what angle is that? Must be a 45. Now, could there be another answer? Yes. This is where you have to think it through and say, where is cosine positive? Oh, students, take calc. Cosine's positive both here, which would give you your normal 45-degree answer. Know why? Because that's the 1, 1, root 2 triangle you should have memorized. 1, 1, square root of 2. And then there's also an answer down here. And the answer is not negative 45 degrees. You can't do that because the answers are only going to be allowed to be positive. So how do I do that? I figure out what this angle has to be all the way around to there. And that's for you to figure out. Tangent equal to 0. Tangent's tricky. You have to figure it out yourself. Okay. Yes? You're right, but if you're doing tangent, tangent is opposite over adjacent. And what if both of them are negative? That could work. Wait a minute, this is cosine. Sorry, this is cosine. It's cosine. And cosine, one of them is cosine is adjacent over hypotenuse, and the adjacent side there is positive 1. It's not negative 1. Okay, anyway, tangent is tricky because tangent can be undefined. Think about that for a second. Tangent can be undefined. All the other ones can't. Sine goes on forever. Sine won't be undefined. Sine of like 30, sine of 60, sine of any big angle, it doesn't matter. If I just keep going long enough, sine will get to every angle that there is because it goes forever, right? But tangent, you remember how tangent looks if you graph it? Tangent looks like this. So you have to be careful because there's 2 spots right here and here where tangent doesn't work. Tangent's undefined. So if they ask me to find tangent of, what's this spot right here? What's that spot? Pi over 2. Or what's this spot over here? Negative pi over 2. If they ask me to do those are undefined. Be careful with that. Because normally if I asked you to do sine of any angle, you can figure it out. Cosine of any angle, you can figure it out. But if I ask you to do tangent of some angle, then that could come out undefined. Well, in this case, it doesn't want undefined though, does it? What does it want? It wants 0. So where is tangent equal to 0? The way I would do this is not with a picture like that. I would do tangent with a picture like this. All students take calc, draw the circle, figure out where can tangent be 0. Well, it's not in a normal spot. It must be one of these spots. There, 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 there. So if it's 0 over 1, isn't that the same thing as 0? All right. So that's y over x. Do you remember the tangent's y over x? So many little things to remember, but you have to know all of them. If tangent's y over x, then y has to be 0. Does x have to be 1? No, x can be anything. As long as y is 0, 0 divided by anything is 0. So the real key here is you want y to be 0. Where is that? Where is y equal to 0? Well, this is the spot where y is equal to 1, so it's not that. This is a spot where y equals -1, so it's not that. How about these two? Are both of them spots where y equals 0? Yeah, so those are both. I would know to put both of them. You want to put every answer that works between 0 and 2 pi. But that's an important point. If it's between 0 and 2 pi, this one could be called 2 pi, but you don't want to say 2 pi. Because they're going to say on the directions that they want answers that are between 0 and 2 pi like this. Okay to be 0, not okay to be 2 pi. So this one's 0, and that's one of my 4 answers. There's one of my, wait a minute. I was going to ask you to figure out these. That one was 45, but you figured out in radians. This one's some big answer in radians that's like 360 minus 45, except in radians. This one's 0 degrees, which you could say is in radians by just saying 0. And lastly, we have that spot, which is at, what? Is that pi or pi over 2? That spot's pi. Now, if I realized that, wait a minute, I did one of those 2 spots where tangent is undefined, you better throw it out. But tangent is, I can make tangent be 0. That's okay. It's not undefined to put in tangent of 0 or tangent of pi. Those are both okay things. What were the ones that were undefined again? If tangent was pi over 2 or negative pi over 2, if I was ever doing that, I'd be saying, ooh, wait a minute, that's undefined. All right, moving on. We got to be able to handle things that are squared, like letter D. Let's go to D. Sine x tangent squared x equals sine x. The first thing is, all the ones I was doing, I always set it equal to 0. And this one's not set equal to 0. So all you got to do is move the sine x over to the other side and set it equal to 0. That's like a fundamental in solving these. Get it equal to 0 first. Sine x tangent squared x. And then I'm going to subtract sine x from both sides. So it'll say equals 0. Now I can factor it. See, it just added one extra step, but now it's the same exact deal. Now I can factor the sine out of both of them. Yes, you'll have tangent squared in it, so I'll help you with that a little further. Sine x comes out, tangent squared x minus 1. And then this part, set sine equal to 0. To find a couple spots, that'll work, and that's okay. Sine does equal 0. Think about it on the picture of sine. Doesn't it equal 0? Look at that. It hits it here, hits it here, hits it here. So there's lots of times when sine is 0. Maybe one of those is undefined, though. Or no, one of those is not allowed because it's 2 pi. Anyway, this one, tangent squared x. Let's do one with squared. Tangent squared x minus 1 equals 0. So add 1 to both sides. Tangent squared x equals 1. So then square root. If you square root both sides, what's the square root of 1? It is just 1. A lot of people think that that's positive and negative 1. It is not. Square root of 1 is just 1. But what's the square root of tangent of x? It is the absolute value of tangent x, which means you break it into parts. And you write it twice, exactly as you see it. Tangent x equals 1, and tangent x equals -1. You've got to be able to pull everything together on this test. See, like, I've done this a million times with you. Remember when you take the square root, you get absolute value? I know I've told you that. And we've had that on tests now. And this will be the 5th time you've had it on the test, where you have to take the square root of something, and then you got to know that you do absolute values. Okay, so now I'm down to these 2 things. Can you see how those might have 2 answers each? So I could have 2 answers for this, 2 answers for that, and I already had 2 answers for this other one, so I could have 6 answers for this problem. All right, so down to tangent x is equal to 1. How do I do that? You got to be able to figure these out with your circle and say that spot's 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And what am I looking for? This is the y over the x. So y has to be 1. Where is y equal to 1? Only right there. Am I doing this right? Something feels wrong about this. Oh yeah, you can draw a triangle for this one. It's not one of these places. You know why? Because y has to be 1 and x has to be 1. Right? So there's none of these spots where y is 1 and x is 1, so that won't work. So thank you. That's what was wrong in my thinking there. So I'm going to now make a triangle where it is 1 and 1. Tangent is opposite over adjacent, right? 1, 1. And then the other side, square root of 2. We were just talking about that one. So what angle is it? 45. Good. Also known as pi over 4. Good. 45 is pi over 4. And then you got to remember, all students take calc. Where is tangent also positive? Down in here. So you got to make another one down here that also has a 45-degree angle right there, but that's not really 45. You got to figure it out in terms of, well, if you wanted to, you could do it in degrees first. That'd be 180 plus 45, you know, because 180 to here plus another 45. So 180 plus 45 would be 225 degrees, and then you could change it to radians. Or you can think in radians and say, these are pi over 4s. That's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4. So that spot right there is 5 pi over 4. There's one of my answers. This one was pi over 4. That's my other answer. 1, 2 answers. Now I got to figure out this one. Negative 1. It's the same exact thing, except it's in the other two quadrants. Because you can make a triangle here and a triangle here. I'll let you finish that. All right. So squared, when you see squared, remember that in the problem somewhere you're going to take the square root. When you take the square root on both sides, you'll probably end up needing to get that a positive and a negative. Or sorry, you'll get two different solutions to solve. All right, let's do one more where it's quadratic. Look at 2b as in banana. 2b. These are your homework problems I am doing with you, so I encourage you to stay with me on them. I know you might want to go ahead, but do the ones I'm doing with you, and if you have time in between, go ahead. 2b, 2 sine squared x, and then I got to go plus 3 sine x plus 1. And it's already set equal to 0. That's a good sign. Now you got to know 2 sets of parentheses. How do I make a 2 sine x or sine squared x? I have a 2 sine x and a sine x. You get how when I multiply those together, I'll get 2 sine x squared. And then I just got to figure out what numbers go here and here so that when I do first, outside, inside, last on it, it'll equal this. Oh, there's a big hint here. The 2 question marks, what do they have to multiply together to equal? 1. If they have to multiply to equal 1, well, they must be 1 and 1. And the only exception would be if they were negative 1 and negative 1. But since this has got a positive in the middle, it must be plus 1 and plus 1. Hey, that was easy. So these are factoring like that. Now, once you've got it set so that it's a multiply problem like this, then this part has to equal 0, and that part has to equal 0. And you get 2 answers on the one side, 2 answers on the other side. Okay. All right. This is going to be a little too long if I assign all of it. Well, you know what, though? You're assigning not. I forgot. I'm not assigning it all for tomorrow. I'm teaching it all today, but remember you have a work day all day tomorrow. So I am going to assign all the rest of these. I did a bunch of them in class. Got to admit, I usually don't do that many of your homework. Now we're going to move to the other worksheet, and it's called worksheet 5.3, number 1. I'm going to pause for a second while I hand it out. Okay, the new worksheet is called 5.1, number... Wait, no, I'm wrong. 5.3, number 1. 5.3, number 1. Yes, all the answers should be in radians unless it's not that kind of a problem. Like this one today, the new worksheet that I'm about to do for you, 5.3, number 1, doesn't have radians in it. Well, sometimes they do. Sometimes they have degrees. Okay, I need you to get the main idea here. There is formulas that are in the box at the top of the page. Do you see those? Did we ever give you the formulas before? No. That means that on this type of question, on the test, you will be given these exact formulas because we don't expect you to memorize them. They're not insanely hard. I have some of them memorized, but I don't even have all of them memorized. So our formulas are good to be able to use, but we don't need you to memorize them. Okay, so let's look at number 1, sine of 15 degrees. Why is that tricky at all? Just because you won't be able to use a calculator. And if you're supposed to figure out sine of 15 degrees without a calculator, you can't just, like, unless you're a human computer guy, you can't just say, it's square root of 3 over 5 or whatever. You'll have to do it with one of these formulas. Take a look at the top of the page. Which of these formulas do you think applies? The sine, the cosine, or the tangent one? Probably the sine one, okay? And I'm going to, just for the people watching at home, regurgitate that formula like the mama bird. Sine of alpha, that is. And then it says plus minus beta. And that's equal to sine alpha. I'm making terrible alphas here. I need to move this over. Sine alpha cosine beta. And now this is important to notice. It says plus minus and the other one says plus minus. If it had said minus plus, do you know what that would mean? You would want to switch the sign to whatever it... See, this allows for it to be plus or minus, right? Add or subtract. And if you start with an add problem, then you stay as an add problem. Or if you start with a subtract, you stay as a subtract. Look at the other formula on the sheet. Do you see the other formula on the sheet for cosine there? You see how it starts with a plus minus? And then in the formula later, it says what? Minus plus. That means you should change signs. So if they give you a plus and you're in the cosine formula, you change it to a minus when you're doing your answer. Okay, so back to, I'm just finishing off this formula. The rest of the formula is for sine is cosine alpha sine beta. Cosine alpha. My alphas are awful. You just never use those. Alpha sine beta. Okay, so how do I use this? Just like most formula problems, you just have to plug numbers in and make it work. And it'll be really nice once I figure out alpha and beta. Do you get, as soon as I know alpha and beta, I can just like plug everything in here? So what you have to ask yourself is, what numbers could I put here, and what sign should I use so I get a 15? What could you add together to make a 15? Well, we could use 10 and 5, but does anybody have memorized sine of 10 and sine of 5? Because later on we'll have to use a 10 and a 5 here and here and here and here. Do you get how I don't want to use 10 and 5? 30, you know, yes. 30 and 45, I know both of those. You'd have to subtract that, exactly. So, tell me what to change this to. You just said it. Sine of what? 45 minus 30. And I know both of those. I can do sine of 45 and I can do sine of 30 because I have those triangles. So if it's sine of 45 minus 30, because 45 minus 30 is 15, then I'm going to do sine of alpha, and what was alpha again? 45 times cosine, notice me changing colors, cosine of beta, which is 30, and then, minus plus plus minus, is it the same sign? Yeah. See how it's important right now to know that I used a minus and I should use, this is the same as this, so I should use the same sign. Minus Now I got to do cosine alpha sine beta. So cosine 45, changing colors again, cosine 45, and then I got one last color, green, sine 30. Do you get that once I figured out it was 45 and 30 that's been easy so far? You won't be able to use a calculator to deal with it. Okay, I know, that would be a lot easier, but this is one of your easy questions. It is. It is. This is easy. Oh, not quite. Do you get where I got all of those from? All I did was stick in a 45 and a 30 and a 45 and a 30 into the formula. That can't be the hard part. That's the easy part. Okay, now here's the if that was the plugging part, then this next part is the chugging part. Okay, so this isn't that bad though. Sine of 45. Do you remember answering that? Do you remember answering that on your first few trig tests? It was stuff like sine of 45. Sine is opposite of hypotenuse. Remember, you just figured it out from the triangle, right? So how do I do sine of 45? I'm going to recommend that everybody at the top of your page make a nice 45, 45, 90, and 30, 60, 90, because you're going to use it on this assignment over and over and over and over again. So at the top of your page, make what I'm making here. 1, 1, square root of 2. And that's the 45, 45, 90. And what's the other guy you have memorized, I hope? 30, 60, 90. Looks like this. 30, 60, 90, 1, 2, and the square root of 3. Okay. So how do I find sine of 45? I go to the right triangle there, the 45 one. How do we sine? I can pick either angle. That's the easy kind. Sine of 45 is, I pick either one. I'm going to pick this one. Sine is opposite of hypotenuse, 1 over square root of 2. 1 over square root of 2. Times cosine. Cosine of 30. Cosine of 30. There's 30 right here. Cosine of 30. Cosine is adjacent over hypotenuse. Adjacent is root 3 over hypotenuse is 2. Root 3 over 2. Now I know some of you are like, yeah, sure, easy for you. This really, each little individual part was like an R2 question. Seriously, every part of this is just an R2 question. It's just that there's like 75 R2s put together to get one answer. Minus, this might give you some happiness to know that I have to take a gigantic math test on the last day of school. It's true. For my national board certification thing, I have to pass a 3-hour math test. And I'll be taking tests like this, except other math teachers get to make up hard problems for me, and yeah, it's not easy. They have calc on there, and I've never taught calc, so that'll be a challenge. So anyway, there's going to be hard parts. I'll have some parts nailed, like there's a pre-calc part. I'm feeling good about that, but there's a calculus part that I'm a little scared about, and there's also something on like heavy-duty, something called like Euler's circuits or something I haven't even studied yet, so I have to go. No. I actually, they don't keep it as simple as percentages like that. They want me to score basically just, I think I'll pass the math test. I think I'll get good enough on the sections I know really well. I'll get really high percentages, except they're in scores of 1, 2, 3, 4. You know what I mean? So I want 4s on those. These ones are good for me, but I'll probably get 2s on the other sections. But on average, I'll average a 3, and so I'll pass the math part. The harder thing is that there's this, the whole rest of the national board thing is really hard. There's just so many, 70 pages of writing. That's all I did over break. I got 38 pages now so far. And they're like, not just writing, it's rewriting it. So it's a tough process, but just know I have to study for a really hard math test too. Hardest math test I have taken in 25 years. I'm taking it on the 12th. You'll already be done with school. June 12th is my big D-Day for that. So anyway, it's not just you studying for a hard math test. It's me too. All right, cosine of 45. Cosine. I'm in this one. Cosine, ka. I talk myself through it like this in the real world, except it's a little quieter inside my head. cosine is adjacent over hypotenuse 1 over square root of 2. And then the last one is sine of 30. Ooh, I memorized that a long time ago because server said I should. 1/2. If you didn't know it, you'd have to look it up in the triangle. And then, do you notice that you have something, and this is really nice. It happens to work out this way all the time. You've got a common denominator already built into the problem. You see that? Root 2 times 2, and root 2 times 2, it has a common denominator. So I don't have to make common denominators, but I have to know how to put this all together. The final answer has a common denominator of 2 root 2, 2 root 2, and then what's on top? Well, 1 times root 3, which is root 3, and 1 times 1, which is 1. There's my final answer. That's all you have to do. After those 75 steps, you're done. It might have been a little less than that. All you'll have to know is the 30, 60, and 45s. Yes. All right, so let's do another one like that. Let's try cosine of 75. Let's go to number 4. Now I can tell this worksheet's probably a little too long, even with the fact you have tomorrow to work on it. But let me help you with number 4. Cosine of 75. Any nominations for what I should change that to? Remember, we got to do stuff that we know already. Ooh, a 30 plus 45. Very good. So I'm going to change that to cosine of 45 plus 30. Does it matter which order? Nope. You could have said 30 plus 45 and it'd be just fine. And then if you had it memorized, it would go faster, but we do not expect you to memorize it. It's going to be given to you on the test. So I'm given that formula for cosine, which is cosine, cosine, sine, sine. That's the way I like to do it. But, and it's a big but. I won't name, yeah, anyway. It's a really big, important thing. This is a plus, so notice in the formula, plus minus turns into minus plus. It's a minus right there. That'd be really easy to forget, wouldn't it? Yep. Whatever the sign starts as, because remember, we could have made this a subtract if we wanted. Whatever you start for this, though, if that's a plus, then that has to be a minus. Okay. Now, I like to not put in the alpha and the beta. I like to just write cosine, cosine, sine, sine, and then I'll stick the numbers in later. The numbers are 45, 30, 45, 30. You always just do them in the same order that you have them. So 45, then 30. Okay, now I have to get out my triangles again. I can draw them really quick. 1, 1, root 2, and this one's 30, 60, 90, so that's 1, 2, root 3, and that's a 30, and that's a 60, and that's a 45, 45. Okay, good enough. Cosine of 45, adjacent over hypotenuse 1 over root 2. Cosine of 30, cosine of 30, cosine is adjacent over hypotenuse root 3 over 2. Is it the same thing? Yeah. Oh, awesome. Okay. So they will always have common denominators. They won't always come out to the same thing, but they'll always have a common denominator.
We'll never have to do our own common denominator?
You will not have to make your own common denominator. That is true. Okay. So let's move on to a different kind.
Do like 7 or 8.
I agree. You should do a tangent. So let's do number 7. 7. I know that's a good one because it's got a 5 pi over 12 in it. You know, like before where we had to divide this up into like a 30 plus a 15? We have to divide this up into a tangent of either something plus something or something minus something. On this one, what are some of those pi overs that you have memorized? Well, it's 30, 60, and 45, so... Is this a problem? This should be a... Sorry.
No, that's right.
I'm confused. Hold on. Number 7 is 5 pi over 12. Have I got it correct so far? Oh, I see what you're saying. You're giving me a possible answer. Go ahead. So If I'm going to use radians, though, what should I use?
Are you, why are we minusing? Would you keep it in radians?
You can change it into degrees. Okay, that's what you're getting at. All right. The question was, could you change this radian 5 pi over 12 into degrees? Yes. If you want to do the problem in degrees, you can. But honestly, I think it's not a bad idea to know how to do this in radians. I think it might be easier, but let's just try it for a second. Would you agree that you know 30, 60, and 45? Then what are they in radians? Pi over 6. What else? Pi over 3 and pi over 4. But what if they were in 12ths, like the problem is? Then it would be 2 pi over 12, right? What else? 4 pi over 12. You just times by 4 on the top and the bottom. That's okay. And how about the last one? 3 pi over 12. Now, oh, come on now. You get this much, right? Those are all things you memorized, right? Okay. And all I'm doing is changing pi over 6 into 2 pi over 12. That's changing into 12ths. Why? Because the problem's in 12ths. Okay. So back to, how could I get a 5 pi over 12? You got it. 2 pi over 12 plus 3 pi over 12. That would make 5 pi over 12, wouldn't it? And now, at this moment, wouldn't it be okay to change them over to degrees? Yeah, it would. And if I change this over to degrees, that would really be, what's 2 pi over 12 really? 30 plus, what's 3 pi over 12? 45. So, I wanted to show you how to do that with radians. But how many of you think it would have been easier if I would have just changed this into 75 degrees in the first place? All right. So that's maybe what you should do. And that's what she was suggesting. Okay. So that's a good start. Now I got to actually figure out what to do. Tangent, what's the formula thing for tangent? Oh, tangent over 1 minus, or 1 plus, tangent. Okay, so tangent over 1, and I got to figure out the sine, but then it's going to be tangent. And now I got to figure out the sines here. Notice it says tangent of alpha plus minus beta, and on the top it's plus minus, and on the bottom it's minus plus, which means I use the same sign. So since I'm using plus, do you agree I have chosen plus? Since I'm using plus, then this formula needs to be a plus on the top and a minus on the bottom. Now I got to put in the right degrees. What are they? 30 and 45. 30 and 45. 30 and 45. So now I got to figure out tangent of 30. Wouldn't it be nice to have the triangle drawn somewhere? Yeah, you guys do on the top of your paper. So you can go, I can see it in my mind. Tangent is TOA, opposite over adjacent. The opposite side's 1, and the adjacent side is square root of 3, right? So this one's 1 over root 3 plus tangent of 45. TOA, opposite over adjacent. Tangent, that's 1 over 1, isn't it? I think that's 1. Over, on the bottom, 1 minus tangent of 30. Well, I just did that one. Cool. So root 1 over root 3 times 1. That one doesn't have a common denominator. I guess I spoke too soon. The tangents you'll have to figure out a common denominator for.
Can't you just flip and multiply and then explode the common denominator as 1?
I like the thought, but you have to get a common denominator first before you can do that. This times by 1 doesn't really do anything, right? So put this over 1. And now how do I get a common denominator here and here? This one needs a common denominator on top, so does the one on the bottom. So you get a common denominator by multiplying by root 3 over root 3. Did I tell you this test might be kind of hard? Root 3 over root 3. You have to just bring everything in that you know. You have to know common denominators. You've known them for a while. if you were always faking it before and you never really knew common denominators, yeah, you're going to get stuck now. Top comes out to 1 plus root 3 over root 3 times by the bottom, except we got to flip the bottom. First I multiply it together, and then I'll flip it. Multiplying it together, I get root 3 minus 1 over root 3. Now I'm going to flip it. Root 3 over root 3 minus 1. So, why did I flip it? Because instead of dividing right here, I'd rather flip and multiply. Now, what? On this one? Okay, let me check and see if it is supposed to be. It's right here, root 3 minus 1. It is supposed to be root 3 minus 1. Okay, so those cancel, and in the end, this one would have been an R3 plus. Right there. Okay. Now, I have one more suggestion for you. I'm going to let you skip some, but I don't cross them out like with really dark ink so you'll never could do them. Just for tomorrow, or like when you're working on these tomorrow and you got to give them to me by Wednesday, you should skip these for now to save your sanity. Not everything, no. So I think we should skip, let's see, we've already done one, like you could skip probably number 5. You could skip number 8. You could skip number 9. You should do number 10 because it's got a negative in it, and you'll have to think, how can I make something add together to make a negative pi over 12? All right, and remember, could I change pi over 12 into degrees? Yes, and you can use that multiply by root. Okay, hold on just a second. So that's, we were in the middle of skipping some stuff when a guy walked in, so now I'm back. We're going to go to the back side and skip some. I think, to be realistic, what I could expect of you realistically is half of those. So why don't you skip the right column? Yeah, absolutely. I'll do one of those for you here before we're done. So let's look at number 11, for example. Sine 42 cosine 17. What on earth is happening there? You just have to take an answer. It's sort of like Jeopardy, where they say, the answer is Cuba. And then you have to say, like, what is the crazy state that's just south of Florida? And, you know what I mean? You have to answer with the question. All right, so this is like they've given you the answer. The answer is sine 42, cosine 17, and minus cosine 42, and sine 17. And you'd have to say, oh, I recognize that pattern. That's that cosine, sine, cosine, sine pattern. Look at the top of the page on the other side. Which one has cosine, sine, cosine, sine? That must be the top one. It must be sine. And then, was it an add or a subtract? It was a subtract. So sine of something minus something. And then last, what goes on the inside of that parentheses? 42 and 17. And then if you can actually subtract those two numbers, you'll have the answer. Sine of 35? Okay. I'm going to double check it now. 25 plus 17, 30, 40. Yes, 42. There we go. So sine of 25. And notice it's set in the directions. Write the expression as the sine, cosine, or tangent of an angle. And I did. So they gave you the answer and you had to figure out the question. That's how you do the kind on the backside. I know, that's a lot to learn, but hey, that means tomorrow you got all day to work in class. Don't hurt yourself by not doing any homework tonight. Do some tonight, work on it tomorrow, work on it tomorrow night, and I'll see you Wednesday. That's all I got for the review for today.